Chapter 3, Topic 3.5, Archaea. In this overview, I'm going to be very brief because we won't be spending much time on Archaea. This is the frontier of my microbiology. It's exciting, but this is an introductory course. So we're going to talk about these other prokaryotes and the differences between Archaea, bacteria, and eukaryotes. We didn't realize that there was a group of organisms that were so different they would cause a new taxa, the domain, to be developed until we had molecular biology technology. The differences are not in shape, although this one is pretty funky, or other characteristics that you can see with a light microscope. They just look like other bacteria, but they are more closely related to eukaryotes than they are to bacteria. Now make sure that you learn this chart of the differences between Archaea, bacteria, and eukaryotes. You will be tested on it. Let's go over some of the things that make Archaea different from bacteria, and some of the things that make them similar. They both have a singular or few circular chromosomes. Eukarya usually have several and they're linear. Both bacteria and Archaea have a 70S ribosome, but the structure of the archaeal ribosome is closer to the 80S eukaryote ribosome. Here's one that makes them different from both. Both bacteria and eukarya have fatty acids with ester linkages in their cell membranes. In other words, they have a lipid bilayer. Archaea have a long chain branched hydrocarbon with ether linkages. Basically, that means it's one long chain with a hydrophilic end on each end. They have a lipid monolayer, in other words. Isn't that weird? I think that's weird. We used to think that Archaea lived only in extreme environments, such as acidic hot springs in Yellowstone, airless swamp mud, salt lakes, and such. But now that we know how to look for them, we are finding them everywhere. We are finding bacteria in the same extreme environments as Archaea, so environment really isn't considered a difference anymore. In fact, one of the places that we are finding Archaea is in the spaces between your teeth at the gum line. We don't know that they cause periodontal disease like this, but this was a good picture showing the spaces where bacteria grow in your mouth. I have a crash course video for you to watch about Archaea, bacteria, and protists. It gives a good chapter summary and an introduction to the protists in the next chapter. Hank does make a few mistakes though, and I'd like to clarify them. Bacterial chromosomes are not plasmids. Bacterial chromosomes are circular pieces of DNA. Plasmids are circular pieces of DNA, but they're different. We don't know if Archaea are older than bacteria. The archaeal fossils that Hank talks about can't be identified as either Archaea or bacteria to my knowledge, and molecular evidence suggests that ancestors of bacteria and Archaea eukaryotes split off from each other before the ancestors of Archaea and eukaryotes split off. We don't have those ancestors around, but it would still make bacteria the older lineage. That's it for this topic. You should now be able to list some differences between Archaea and bacteria, and also list some similarities between Archaea and eukaryotes.